To 4.14, we're going to interpret a graph or a table of points for a trigonometric model in the context. So we're going to actually be looking at real-life problems and using our knowledge of sinusoidal functions to make sense of the data. First, I want to go ahead and look at what we were discussing on Friday. So here is the two functions that we were comparing. F of x is a bunch of points that they give us. They tell us it's an exponential function. And you can see here it's an exponential function, and that it clearly the b value here must be less than 1, right? Because as the exponent gets bigger and bigger, my value gets smaller and smaller. So think about it. Imagine that b were 1/2. So think about having 1/2 to the 10th power, for example, right? That would be 1 over 2 to the 10th. It's a very, very small number, and so that would be getting smaller and smaller. And then we have g of x, which is a sine curve, and I can graph that pretty easily. I know the period is, and this one might be a little tricky, so x divided by 3 is the same as 1/3 times x. So my period is going to be 2 pi over 1/3, and when I divide by any number, it's the same as multiplying by its reciprocal. So it's 2 pi times 3 over 1, which is of course 6 pi. So that's a pretty big distance, pretty big period. It's very stretched out. Midline is at 2, and it's a negative sine curve. So what I do is I go about graphing it, and I'm looking for the first minimum or maximum point. And I know that sine itself has a maximum when it's at pi over 2. So I ask myself, what will make the input, x divided by 3, what will make it equal to pi over 2? So I set it equal to pi over 2. And what I end up doing is just multiplying by 3 on both sides. Just like that. Those will cancel. I find that the x needs to be 3 pi over 2. So that's where my next minimum or maximum is going to be. And I know that sine of pi over 2 is 1, but there's a negative out front. So it'll be -1 plus 2, which is +1. And then I can also do the same thing for -3 pi over 2. When I plug that in, I'll get sine of negative pi over 2. -1 times -1 is +1, so I'll be at 3. And that will help me answer these following questions. So it's pretty clear that f of x is going to have a larger y-intercept. Now notice I didn't have to graph the functions to discover that, because if I'm looking at my sine curve, there's no phase shift, so I know it begins at the midline, its y-intercept, and its midline is at 2. And if I look here at my table of values, well, at -1, I'm at 8. Okay, so think about -1, you're at 8. And then at 2, I'm finally getting to 1, right? So if I'm thinking about an exponential function, there's no way that I could possibly cross 2 and then, somehow shoot up. So the exponential function is definitely going to have a greater y-intercept. Compare the behavior of the functions as x is approaching infinity. So as I scoot out further and further in the right, what's going to happen? Well, f of x is going to get smaller and smaller and smaller, but g of x is going to oscillate between 1 and 3, continuing on. It's going to continue its pattern. So you want to mention how one of them is just going to get smaller and smaller. It's going to approach its asymptote of 0, while the other one is going to keep working back and forth. What is the sign, positive or negative, of each function on the interval -2 to 2? So I'm thinking about -2 to 2. Well, -2 might be somewhere here, and +2 might be somewhere here. So looking between this interval, it's pretty clear that both of these functions are positive, right? Both of them have y values that are above the x-axis, and so the sign of each function is going to be positive. And then graph them, of course, to make sure that your answers are correct. So here's the graph. So hopefully that was a good explanation for you. If you have any questions, make sure to write them down. Now we're going to go on to a new problem, but it's really going to be involving similar things that we have already been working on. And pause the video at this point, read the question, copy down the graph here, and give it a try. This is kind of a problem to help walk us through what we would do if we were modeling some data with a sinusoidal function. So it's pretty clear that this data is going to follow a repeated pattern, and so in order to model it, we'll want to use a function that is periodic or repeats itself. So I'm not going to give you a whole lot of tips because really everything that you need to do is in the questions. What I do expect is a couple of things. In your comment, I want you to write the answer that you have, write a function that would model this data. Okay, so the answer to part C needs to be written out in your comment. And then the second thing is to make sure that you have a question or answer someone else's question in relation to this problem. So make sure you have C written out in your comment along with the question or the answer that you are providing. Have a good weekend. I'll see you tomorrow.